Welcome to This Explainer. Today, we're unpacking the realities of industrial machinery procurement in 2026. Look, if you're sourcing a CNC lathe this year, you already know the landscape has completely shifted. It's no longer just a basic equipment purchase, right? It's a massive, strategic investment that is going to dictate your competitive edge for years. So instead of just staring at the sticker price, we're going to uncover the true long-term return on investment, balancing those high-precision multi-access capabilities with serious integrated automation.
Okay, let's dive right into this. It's literally the most common trap in industrial sourcing, staring at that initial quote and just letting it drive your entire strategy. But you have to ask yourself, is that sticker price deceiving you? If we buy based solely on upfront cost, we might actually be setting our production lines up for a massive financial drain down the road. To achieve real efficiency, we've got to look way deeper than day one.
And that brings us to the core metric of this explainer, total cost of ownership, or TCO. Think of this as the comprehensive life cycle cost of your machinery. We're combining acquisition, operational, maintenance, and training expenses over a 5 to 10-year period. Understanding this exact metric is what mathematically justifies spending more upfront, because over a decade, a premium machine yields significantly lower maintenance costs and a much higher resale value.
Let's break down this TCO iceberg, starting with that very first layer, the realities of acquisition. The base machine unit is obvious, but what about specialized tooling add-ons? Those can inflate a budget in the blink of an eye. Plus, international shipping and freight insurance are massive variables right now. Factoring in an extra 4 to 6 weeks for sea freight means transit costs absolutely need to be calculated into your day one capital outlay. You just can't treat them as an afterthought anymore.
Moving to the second layer, operational expenses. Honestly, this is a non-negotiable factor in 2026. With industrial power costs rising globally, a machine's energy efficiency rating is now a critical pillar of your lifecycle costs. Think about it. If a cheaper machine drains twice the electricity to hit the exact same cycle times, those initial savings you thought you had, they'll be completely wiped out by your utility bills over the next 5 years.
Then we hit the third layer, which is where long-term capital literally goes to die: maintenance, downtime, and training. It's so crucial to ask, if this machine goes down on a Tuesday, what is local service technician availability actually like? Are we trapped by an incredibly expensive proprietary spare parts, or does the machine use universal components? And let's not forget operator upskilling. Training a team on brand new software costs you both production time and direct capital. Thinking about that software point for a second, let's look at a classic industry choice: the FANUC controller versus the Siemens controller. Your choice here should actually depend heavily on your existing operator skill set. FANUC is essentially the industry standard for general turning, renowned for extreme reliability and global parts availability. On the other hand, Siemens offers a highly intuitive graphical interface and superior performance for complex multi-axis milling tasks. Picking the wrong one? Well, that means weeks of expensive retraining.
This brings us to the technical evaluation phase, balancing underspecking against overspecking. It's a total tightrope walk. If you overspec and buy features you'll never use, you're essentially buying a Ferrari just to drive to the grocery store. You're burning valuable capital. But if you underspec just to save a few bucks, you instantly create bottlenecks that throttle your daily output. Your technical requirements have to be crystal clear before you ever send out a request for quote.
Now, what's really interesting about these essential physical limitations is how they act as your very first crucial filter. You have to consider the absolute largest and smallest parts you plan to manufacture. Swing over bed dictates your maximum part diameter, while max turning length and distance between centers ensure stability on long shafts. And if you're using automated bar feeders for high-volume work, your spindle bore diameter must be perfectly sized for your raw stock. It's absolutely foundational.
Beyond the basic dimensions, the spindle is truly the heart of the lathe. Your spindle performance dictates what materials you can actually cut. You need high RPM for non-ferrous metals, like aluminum, but high torque for hardened steel or titanium. And consider your tooling. A machine with 16 turret stations reduces manual changes dramatically. But the real game changer in 2026? Live tooling. This allows for one-hit mill-turn machining, meaning you might be able to eliminate the need for a separate milling machine entirely, saving you massive amounts of floor space and labor.
Matching the right machine type to your exact sector is absolutely vital for TCO. For instance, if you're in the medical or electronics sector, you're navigating the high sourcing complexity of Swiss-type lathes for tiny, high-precision parts. Meanwhile, Tier 1 automotive suppliers lean heavily on slant bed lathes for high production chip flow.
Choosing the wrong category here doesn't just hurt your efficiency, it completely breaks your entire production model.
Geography also plays a massive role in TCO because a region's build philosophy really dictates the machine's longevity. Japan and Germany remain the gold standard. They're built for relentless 24/7 high-intensity environments. Taiwan is widely considered the value-precision sweet spot, offering robust casting and reliable electronics at mid-range prices. And in 2026, mainland China isn't just about fast lead times anymore. Their top-tier brands have become highly competitive in the high-end multi-axis segments. Where you source from fundamentally shapes your maintenance future.
Let's move to and see how this builds into a truly actionable plan. To protect your business from those long-term financial drains we talked about, you have to adopt a strategic 3-step procurement workflow. Technical RFQ alignment, factory audit and verification, and performance testing. This is designed specifically to mitigate risks before a single dollar ever changes hands.
Step 1 is technical RFQ alignment. Look, it turns out sending out a generic request for a CNC lathe is a massive risk. Your RFQ needs to be exhaustive. State your material hardness in HRC, define exact tolerance levels down to the micron, and explicitly specify the controller brand. Being ruthlessly specific here is your ultimate shield against bait-and-switch tactics, where a supplier quotes an unbelievably cheap price but then plans to deliver a machine with completely unsupported electronics.
Step 2 is factory audit and verification. When you're dropping upwards of $50,000 on industrial equipment, verifying the factory's standards is absolutely essential. Look for ISO 9001 certifications and ask if they use Renishaw ball bar testing and laser calibration for quality control. It's also incredibly smart to demand subcomponent transparency, like where are the bearings from? Are they SKF, NSK? What about the ball screws? If a supplier won't tell you, it's usually a clear sign to just walk away.
Finally, step 3 is performance validation. Instead of just taking a supplier's word for it, it's incredibly helpful to send your actual raw material samples to their factory and request a test cut video. Better yet, leverage the 2026 sourcing environment. Top-tier suppliers now offer high-definition virtual live streaming. You can literally sit right in your office, watch the machine cut your part live, validate the cycle times, and inspect the dimensional precision, all before finalizing the purchase.
Now, even with the absolute best machine, things happen. Warranty management is a huge part of procurement realism. Here is a crucial insider tip. Do not wait for a part to break to figure out shipping. You should negotiate a critical spares kit upfront so it ships with the machine. If a machine goes down, waiting weeks for a replacement part from overseas causes a massive spike in your total cost of ownership due to lost production time. Also, ensure your contract formally includes remote video support.
Remember, true procurement realism means customizing this whole strategy based on your unique business model. Small buyers should look for all-in-one packages with really strong English support. E-commerce sellers making micro parts, you should laser focus on Swiss-type manufacturers. Brand owners need to negotiate custom exterior branding and priority service exclusivity. And if you're a bulk buyer, your #1 priority is ensuring the lathe has seamless compatibility with robotic arm loaders and centralized factory automation software.
So, the crucial point is captured perfectly right here. The cheapest machine often becomes the most expensive over time. When we factor in the relentless drain of operational costs, the sting of proprietary maintenance, the downtime from a lack of local support, and the eventual loss of precision, those initial sticker price savings, they evaporate entirely. TCO is the only metric that tells the truth.
By prioritizing the total cost of ownership and insisting on rigorous verification, you secure a machine that keeps your production line highly competitive for years to come. So I'll leave you with this to think about as you prep for your next big equipment purchase. What hidden costs are lurking in your current sourcing process? And what will you uncover in your very next machinery RFQ now that you have this framework? Thanks for joining me on this explainer, and happy sourcing.